Good morning, good afternoon, good evening, depending on when you get to watch this video. This is Uncle Sam, and in today's class, I am here to talk about math. And in today's class, we're going to be discussing the concept of indices. But before we go into that fully, I want to briefly introduce myself on this platform because this is the first time I'm going live on YouTube to teach. My name is Samson Uchechukwu. I'm from Anambra State, Nigeria, which is in western part of Africa. I'm a recent graduate. I graduated 2025 and I studied electronic and computer engineering. And here I am doing what I love doing, even from my early days before I got into the university, which is trying to make the concept of math as simple as it can be. I love not just how of solving math, but also exploring the why. And that is what I want to bring on this space. I started a brand in the year 2023, which is Uncle Sam Online Tutorial, which is basically what you see as the name tag of this YouTube channel. I started it when I was still in my 200 level. I said to myself that I'm not going to leave university without starting something, no matter how small it is. I wanted to start up something so that at the end of my university days, I'll be able to scale up. And I finished last year, and now I'm trying to build up this brand. And the goal is this. The goal of whatever I'm doing is this: to transition you beyond knowledge to gain understanding. And this we do by exploring concepts related to math for now. So we're going to be breaking down a lot of things, breaking it down in a way that is going to be suitable for all to be able to assimilate. So what I'm going to be doing now is this. What I'm going to be doing now is I'm going to be talking about the concept of indices. But before I proceed, I want to hear one or two things from you guys. Can you guys hear me clearly before I proceed? Please, you can use the chat because I can see your chat from here. Please, if you can hear me currently very, very well, please say something in the comment section. I'm from Nigeria. Okay, you're from India. Player gaming, nice. So good to have you here. So good to have you. Thank you so much for joining. I really appreciate you. So like I said, can you guys hear me in real time? Can you hear me in real time? Am I lagging of any sort before we proceed? Can you hear me in real time? Can you guys hear me in real time? Okay. Thank you. Thank you, player. Yes, thank you. Thank you. Those joining from here, really appreciate you. Thank you for being here. I appreciate it so much. So for today's class, we're going to go into the concept of indices. And now, one of the things I love about indices is how it is applicable in almost every part of math. Because when you talk about indices, you're talking about the concept of power in mathematics, because indices brings out that power aspect that we so greatly admire and make use of in almost everything that we do in math. So what is the concept of indices? Indices, short form, start from the word index. An index in math has to do with powers. So indices is just trying to tell us that every number or even variable in math can be regarded or can be represented in terms of a base and a power. Indices is gotten from the word index and the same thing as power. And indices, as a topic in math, is trying to tell us that every given number or variable can be represented in terms of a base and a power. These are the two things that define indices. And so because of that, how do we now go about exploring it? There are different laws of indices, but for today's class, let us go into it and see where we'll come to arrive. So if you have something like a variable, A is a variable. Indices is trying to tell us that this A can be represented in terms of a base and a power. And how do we know the base? This A, if it's raised to the power of n, The value on the down part here is one regarded as the base, while your n here is regarded as the power. So this is what indices tries to tell us. And by knowledge of this, we get to do some basic calculation that has to do with numbers or variables that are represented in this format. And so because of that now that we've known that what indices is trying to tell us is that we want to represent variables in terms of a base and a power, we now get on to try to solve or understand the basic laws that govern indices. Is that clear? Are you guys following? So the basic law that govern indices is what we will be considering right about now. So the laws of indices. One, the basic law of indices, the first law is the multiplication law. So what does the multiplication law tell us about? It tells us that if we have a base A, remember the value on the down part is graded as base, while the one on top, the superscript, is graded as the power. So if we have a base A to the power of n, A raised to the power of n, multiplied to A raised to the power of m. So what do you see here? Both of them have the same base. The base variable for each of them is A, but their power is different. And if you are to multiply these two together, what indices or the law of indices under this multiplication law is trying to tell us is this. Because we have the same base for each of the variable here, we're simply going to pick one of the base and then we sum up the power. We sum up the power, so it's going to be na plus m. Now, what is the provision that is made? Provided that both of the variable that you're multiplying or that have like a multiplication sign in between, both of them must be on the same base. You can see here we have A and we have A here. So because they have the same base, we simply go on to add up their power. So it simply means that if I have something of this sort, it is not equal to A to the power of na plus b. We cannot na plus m. We cannot simply add these together. Why? Because they are not of the same base. So this strictly works for values or variables that have the same base. And one of the ways you go about solving this, because some questions usually come where they are not of the same base, but you can find a way to simplify each of the variable given so that they become the same base. So this is the basic thing that the law of indices is trying to tell us. The multiplication law, simply meaning that if you have the same base, you just sum up their power. Secondly, is the division law. If we have a to the power of n divided by a to the power of m. Now you might be guessing right at this point, because since multiplication talks about addition of the power, provided they have the same base, then division is simply going to be the opposite, which is subtraction of the power. So this is going to be taking one of the base, which is a, and then subtracting the power, which is the first one minus the second one. So this division sign here has changed to subtraction. So this is basically what is going on here under this law of indices. Before I proceed, are you guys still following? Any questions so far? Any questions so far? Any question? Any question? Please, you can use the chat box if there's any question. Any questions so far? All right, so I'll just proceed. So this is the basic law for multiplication and the division. So if you're multiplying, you're simply adding up the powers. If you're dividing, you're subtracting the power. That's simply it. Then there's a third law of these indices, which tells us that if we have a raised to the power of 0, that it is equals to 1. Now this is a standard law in indices and it has a proof, and I'm going to be proving it real soon. So simply put, if we have a raised to the power of 0 is equals to 1, but how is that possible? It's possible because how do we get about this? How do you get about a raised to the power of 0 equals to 1? Now simply put, if I want to achieve the explanation for this third law, it simply means I'm going to do something of this. So let's say I bring on 3 as a base and I have power of 2 and then divided by 3 raised to the power of 2. Of course, you know that this is the same thing as take the 2 base according to our basic law, which is the second law of division. We take one of the base, which is 3, and then subtract the power, 2 minus 2, and that's going to give us 3 raised to the power of 0 and equals to 1. Okay? But instead of going through this route, I'll go a different route. This 3 raised to the power of 2 divided by 3 raised to the power of 2 is still the same thing as what? 3 raised to the power of 2, then bring on the division, divided by 3 raised to the power of 2. Right. And so if that is the case now, 3 raised to the power of 2 is same thing as 9. And 3 raised to the power of 2 is same thing as what? 9. And 9 divided by 9 is going to give us 1. So simply put, when you have the same base and they have the same power, it's still the same thing as when you subtract them, it's going to give you 3 raised to the power of 0. And the reason why 3 raised to the power of 0 is equals to 1 is because of this. If we go through this route to solve the equation, we're going to arrive at 1. So this is one of the basic ways, or the reason why any value, any variable raised to the power of 0 equals to 1. So the next law is law of inverse. Next law is law of inverse. So what it simply means is, if we have a to the power of minus n, a to the power of minus n, this is the fourth law, is the same thing as what? 1 over a to the power of n. So this is another way of representing it. Meaning that if I have negative, negative simply means inverse. So it can be, let's say you have 2 raised to the power of minus 3. This can also be written as 1 over 2 to the power of 3. So this over here becomes the negative. This negative here has translated to the inverse, 1 over that particular base raised to the power of 3. And if you look at it here now, you see that the 3 here does not have any negative because this is inverse. This is what the inverse law is talking about. And then if we go to the next one, this can also be in the form of the fifth law, which is the same thing as if I have x to the power, I see using it as a variable, a to the power of n, then close bracket m. If we have this at this point now, this is same thing as a to the power of n m. N multiplying m. And remember that both m and n, both m and n are powers. So if you're having 2 powers, one within the bracket and one outside of the bracket, what you simply do is what? You multiply the 2 powers. So for example, if I have 2 to the power of 3 and then close bracket 2, this same thing as saying 2 to the power of 3 times 2, and that will give me 2 to the power of 6. So this is another law of indices that is very, 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 very important. So this is the 5th law. And then we have the 6th law, which is the last law. Okay, I think it's second to the last. If I have a to the power of 1 over n. Now, a to the power of n is equal to the square root Alright, coming back to this, If you have a base raised to the power of a fraction, it simply means the root of the denominator of the fraction, then the n roots of the a. And so if you have the next one, which is a to the power of, let's say, m over n, it simply means the n root of a then raised to the power of m. So this is how to express this, all the laws of indices put together. And I'm sure that you have a very good grasp of what these laws are talking about now. So what we're going to be doing next is solving some questions under this particular law. So I'm going to clean up here. I hope you're taking a screenshot. Maybe take a screenshot so you'll be able to understand this when you look at it over again. Take a screenshot. I'm going to clean in 5, 4, 3, 2, and 1. So let's solve some problems with these laws that I mentioned here. So you see how we go about solving problems under it. So first question we're going to be solving from my list is, if you have 1, simplify 8 raised to the power of 8 raised to the power of 1 over 3 multiplied to 4 raised to the power of 3 over 2. So let's take this simple question to begin our journey of solving indices related question. Now, if you look at this question now, based on the laws that were written out and we explored before now, you see that none of the laws is quite applicable here because, one, since I told you that indices has to do with a base and a power, and so if we are using any of the laws, then we are considering that the base that we are either multiplying or dividing, they must have the same value of the base. So if you look at this expression here now, you see that both the 8 and the 4, they are not of the same base. So what can we do? This is when people now start finding it difficult. Now, the first thing you can do is tell yourself, ask yourself this question: is there a way I can reduce 8 into a particular number repeatedly multiplying itself? And also, can I do the same for 4? Is there a way I can reduce 4 into a smaller number multiplying itself to get that 4? And yes, we already know that 2 times 2 is equal to 4, and the 2 times 2 times 2 is equal to 8. So is there a way I can rearrange this way that they multiplied into a base and a power? Turns out there's a way you can do that. And how do you do that? Since 2 times 2 is what gave you 4, you can rearrange this to be 2 raised to the power of 2. Yes, because this simply means 2 multiplied itself 2 times, so give you 4. So if you want to represent it in terms of a base and a power, it simply means 2 squared, meaning 2 multiplying itself twice to give you 4. And you can do the same thing for this 8, because 2 multiplied itself 3 times to give us 8. So what we simply do is we take 2 as the base because it is the chief orchestrator in this particular case. And then we'll count how many times it multiplied itself to give us 8, and it's 3. So we'll have 3 here. So simply put, I'm just going to rearrange this, and you see how I'm going to do it. Rearrange each of these variables into the same base, which is 2, and their power. And so to do that for 8 raised to the power of 1 over 3, I'll first of all do 2, because I've reduced 8 to be 2 raised to the power of 3. So I'm going to do 2 raised to the power of 3. This is for 8 first, and then close up the bracket and attach the power of 1 over 3 to it. So once I'm able to do that, I go to the next one, which is 4. I'll replace this 4 to be what? 2 squared, which is what we arrived at. So this is going to be 2 raised to the power of 2 for 4, and then multiply to the outermost power, which is 3 over 2. And once I've done that, it becomes quite easy. I can now apply the power law that I told you about under the laws of indices, which say that if I have a to the power of n and I have a closed bracket m, this is simply a to the power of n times m. So I'll multiply 2 of the powers together. And so if I'm to do that here now, it's going to be this 2, which is the base now that we're working with, and then the power here, which is the original power inside, multiplying the power that is outside. then times, the same thing happens here, 2 raised to the power of 2 multiplied to 3 over 2. This is what we have here. And so if you do that, 3 times 1 over 3, 3 is going to cancel 3. And what you have remaining for these 2 here is that it is raised to the power of 1. Yes, and remember that anything raised to the power of 1 is same thing as what? The 2. It's same thing as that thing. So if I have 10 raised to the power of 1, it's same thing as 10. If I have a to the power of 1, it's same thing as what? A. So just so you know. So if we come back to this now, what I'm simply going to do here is, since this one is now remaining 2 to the power of 1, which is same thing as 1, I'm just making the 1 visible because we are dealing with indices. And with indices, we are mostly talking about a base, which is in this case 2, and a power. So we have to make the power come alive. Okay? That is why I'm doing this. Then multiply to 2 goes to the power of, these 2 here will go and cancel these 2. So what I have remaining is 3. So at this point, I have simplified it. Now they have the same base. And since they have the same base, I can now employ the first law of indices, which is, if you have 2 expressions that have the same base and they are multiplying each other, just simply add up their power. So it's going to be 2, pick one of the base, raised to the power of, add their powers, 1 plus 3. And that will give you 2 to the power of 4, which is same thing as what? 16. So this is how you solve this kind of question. First step, you simplify, find a way to check if there's a way you can simplify the individual numbers there so that both of them can have the same base. That is the way that you solve this type of question. So that is how we go about this. And I hope this is clear. If you have any question at all, you can drop it in the comment section. I will check it out. Okay? And then let's go to another question that we can actually simplify. Let's look at this question together. If we have, give me a moment. Okay, I think this one is quite interesting. I'm going to solve it with you guys. Let's solve it together. If we have 0.2, or let me use 0.5 raised to the power of 3 multiplied to 8 all over 1 over 8. We are asked to simplify this particular expression. And it's still the same process that we're going to employ. But before we get into the process, we need to do some little adjustments. Why? Because here we're having 0.5. And I don't remember us talking about 0.5 squared because it's usually easier that you make it a standard number before you get to solving the particular problem. So what we're going to do here is we're going to switch off this 0.5. I know that 0.5 is same thing as 1 over 2. Yes. So I'm going to rearrange it. It becomes 1 over 2 raised to the power of 3 multiplied to 8 all over 1 over 8. This is what I have at this point. So the next thing I'm going to do is, I have 2 here. I know from one of the rules or laws of indices that if I have something a to the power of minus n, it is same thing as 1 over a to the power of n. So if that is the case now, I can rearrange this 1 over 2 to simply be 2 raised to the power of minus 1. Because if I follow this same rule here, which is if you have a base raised to the power of a negative power, it is the same thing as 1 over that base raised to the power of the positive of that word given power. And I know that 2 raised to the power of 1 is still 1. So because of that, this is actually very correct. I'm going to bring it in here. So I'm going to have 2 to the power of minus 1. Then add its power here, 3. And then I'll go on to reduce this 8. We already stated from this last example that 2 raised to the power of 3 is same thing as 8. Why am I doing that? Because indices is interested with base and power. And we're mostly working with when we can actually effect a change when the variable that we are considering are in the same base. So that is what we're trying to achieve here. So here, this is going to be 2 to the power of 3, replacing 8 with 2 to the power of 3 because it means the same thing. Then this can also be replaced as what? I can replace this 1 over 8 to be 8 raised to the power of minus 1. And if that is the case now, this 8 can also be replaced as 2 to the power of 3, then raised to the power of negative 1. So we can actually do this at this point. We can actually go about doing this. So if that is the case now, I can replace this 8 here, because if this innermost power multiplied the outermost power is going to give us 2 to the power of negative 3. So we can replace it here to become 2 to the power of negative 3. Because 2 to the power of negative 3 is same thing as 1 over 8 if you break it down to the barest minimum. So at this point now, what do you think we're going to do? Of course, we already see multiplication here and this division. So what we're simply going to do is, for this particular one now, we solve it. And I'm going to clean up here to actually solve it. Let me clean up here to solve it. One moment. Let me clean up there. So to clean up here, because we're done with this particular example, to clean up here, to continue here, the innermost power, according to the power rule, the innermost power multiply the outermost power. So this is simply as saying 2 to the power of minus 1 times 3, then times 2 to the power of 3, all over 2 to the power of minus 3. So if that's the case now, I can actually do something quite interesting, but because of simplicity, I'm just going to solve the first one, the one on the numerator part first. Since I'm having multiplication here, this is the same thing as 2 to the power of minus 3 times 2 to the power of 3 all over 2 to the power of minus 3. So if this is the case now, because they have the same base, I can go on and add their powers together. So this is the same thing as picking one of the base for the numerator part, because they have the same base, 2 to the power of negative 3, then plus 3. This plus is as a result of the multiplication sign that you have here. That is what this plus here has switched up to. And then I have all over 2 to the power of minus 3. And this is what you have at this point. So if you solve this, minus 3 plus 3 is going to give you 2 to the power of what? 0. That is what you have here. 2 to the power of 0. Now, 2 to the power of 0 divided by what? 2 to the power of minus 3. So now you bring in the division aspect of this, which is 2 to the power of 0, bring this division up. And then have 2 to the power of minus 3. So we've employed the multiplication aspect of indices. We're now exploring the division aspect of indices. And that's going to give us 2 to the power of, since they have the same base now, their powers is going to subtract 0 minus 3. This minus, first minus here, is for this division sign. And this second one is the one that the 2 here, the base 2 came with as its power. That's what we're having here. And so because minus and minus are together, once two signs are placed together, there's an invisible multiplication sign in between. So negative times negative is going to give us positive. So this turns out to become 2 to the power of 0 plus 3. And that's going to give us 2 to the power of 3, and that is equal to 8. So you see the step by step that we took in breaking this down from the very, very onset. We broke it down. We were given 0.5. We said, no, we're not working with decimals here. We need actual numbers. So we found a way to represent 0.5. And we found that 0.5 is the same thing as 1 over 2. So we replace it there as 1 over 2. And then we now inverted this 1 over 2 to become 2 to the power of negative 1, because that is also very applicable. Anytime you see inverse, the same thing as 2 to the power of negative 1. So we switched off 1 over 2, it became this. And then we switched off 8 to represent a base, which is 2 raised to the power of 3, because 8 can also be represented that way. 8 is same thing as 2 to the power of 3. And I went ahead to do the same thing for the denominator part. This 1 over 8 is same thing as well, 2 to the power of negative 3. And from here, now that we've simplified it by making everyone to have the same base and then have their individual power, we now went on to simplify. And by simplifying, we employ the multiplication and the division aspects of the laws of indices. So this is what we basically did here. Summarize it. We went ahead to first of all multiply these together, and by multiplying, since they have the same base, it meant adding their powers. This is what we have. Added their powers. Minus 3 plus 3 gave us 0. 2 to the power of 0 all over 2 to the power of negative 3. And once you have done that, we now bring this up, this division up. So it now becomes 2 to the power of 0 divided by 2 to the power of negative 3. And if we do that, we give out 2 to the power of 0. Division is minus, and then this 3 has its own minus 3. And then when you have two signs together, they multiply themselves and you end up with a positive. So 2 to the power of 0 plus 3. And then you have 2 to the power of 3, which is equal to 8. I'll solve one more example before we end today's class. It was such an amazing time. So I'm going to clean this up and solve one more question before we call it a day. So let me find the question that we'll also solve, and then we call it a day. So look at this question. We have simplify 27 raised to the power of 1 over 3, okay, minus 2 over 3, multiply to 25 raised to the power of 1 over 2, multiply to 5 raised to the power of 0. So this is what we're asked to simplify. We're asked to simplify this given expression. And I keep mentioning it. The goal of indices is to have a base and a power. And one of the ways you can simplify this type of question is to find a way to first reduce each of the values that you have there into their lowest form. Lowest form I mean is with respect to a given base, a given number, multiply the self successive time to give what values you have here. So for 27, we have to find a number that will multiply itself a couple of times to give us 27, and that happens to be 3, because 3 times 3 times 3, which is something as 3 to the power of 3, will give us 27. So I'm going to switch up 27 and replace it with what? 3 raised to the power of 3, because that is what indices is all about. So this becomes 3 to the power of 3, then close the bracket, put the outermost fractional power. That's what you do here. So I've reduced this for this 27. We do the same thing for this 25. We know that 5 times 5, which is equal to 5 squared, will give us 25. So I'm just going to take this 5 squared and replace it with what? 25. So this becomes times 5 squared raised to the power of 1 over 2. So you see how I'm trying to package everything organized, because mathematics is about having organization, being organized, and then have 5 to the power of 0. So now that I've done that, the innermost power will multiply the outermost power. So 3 goes on to multiply this. So if I bring it out of the bracket, it becomes 3 multiplying minus 2 over 3, then times 5 multiply 2, 5 raised to the power of 2, multiply the outermost power, which is 1 over 2. And then at this point, I don't really have any need for this 5 raised to the power of 0. So I can as well turn this to be equals to 1, because it's a standard. Anytime you have any value, a variable raised to the power of 0, it is equals to 1. So this is equals to 1. Okay? And at this point, this 3 goes on to cancel this 3. So that what I have remaining for this base 3 is 3 to the power of minus 2. That's the only number remaining on top, or the only power remaining on top. Multiply to this 2 here goes on to cancel this 2 here. And what I have remaining on top is 5 raised to the power of 1. And remember, any value that is raised to the power of 1 is the same thing as that value. So if I have 10 to the power of 1, it's same thing as 10. If I have 5 to the power of 1, it's same thing as what? 5. So that is it. So now, at this point now, what do we do? Because neither of them have the same base, we can just employ normal simplification. Is there a way I can represent this 3 raised to the power of minus 2? Yes, according to the laws of indices, I mentioned it earlier that when you have a base raised to the power of, let's say, negative power, negative n, it is something as inverse. Inverse means 1 over that base raised to the power of the positive value of that power. So I can switch up this particular 3 raised to the power of negative 2 to now become 1 over 3 raised to the power of 2. You see now that the power is now a positive. This inverse as well cancelled out the negative here. Then multiply by 5 raised to the power of 1, I already told you, is equals to 5. So this now becomes 1 over, I know that 3 squared is equals to 9, multiply by what? 5. I will know that this 5 has a limit of top 1 because it does not really change anything 5 divided by 1 will still give you 5. So at this point, we just employ normal fractional approach, which is the numerator multiplies the numerator and the denominator multiplies the denominator, and that gives you 1 times 5, 5, and 9 times 1 is 9. So we have successfully simplified this given expression to give us this. This is what we have at this point. I hope that you enjoy this class. I'll be doing this more often and it will only get better with time. Thank you so much for joining today's live stream with Uncle Sam. Thank you, and I really appreciate you. See you in the next class.